Ui, dah live terus. Nampak start keluar video. Oh, ada. Ada suara tak? Press tengok. Ui, dah live terus. Macam mana tak nak share? Sekejap. Tengah fikir. Oh, share kat sini. Okay. Share ke Instagram. Saya akan cakap iblis je. What is this? Okay, sekejap bagi masa sikit. Tak start lagi ni. Dah ajar. Kau keles tengah-tengah malam kan. Saya dah letak link kat Instagram lah. How do you put link on Instagram? I don't know. Wait, maybe like link something like this? No. Yeah, actually I don't know. Wait, how do we put link? Oh, maybe like this link. Oh, there. Let's put this link. Put this stream. Hey, and then put some word. I'm streaming. Oh, what is this? There's some warning over here. What's happening? It didn't start yet. What is this one? Oh, it's just live warning. It's okay, doesn't matter. Wait, let me share. Right, okay, let's start. Okay, do I need a reason why I do this? See, I haven't done calculus for a while. I think I'm gonna use right. I don't have a reason actually to use in the school, because school I'm teaching doesn't have anything to do with calculus. But I guess a friend of mine asked like how to do this, how to do integration. He cannot do. Like more like a student, student. Actually, so I do this more like a studying stuff, studying, like re-studying all the stuff, so that's cool. Okay, I'm pretty sure I know like integration, differentiation, integration. Okay, let's see if I know. E to the power of b. So if you integrate, this one will become b times a, b plus 1. Maybe. Yeah, I don't remember actually. I need to go basic again. Okay. Let's go basic then. Differentiation. Yeah, I might learn something new. Never know. Differentiation and integration. Dude, I don't even know if like someone actually chat with me or not. Let's put it on the side. Okay, differentiation. Ah, yeah. Yes. Where's the most basic one? I shouldn't be forgetting this. This one is like way too basic for me. Or I'm just arrogant. That's my ego speaking, probably. Okay, okay, I see. Okay, let's try this again. Okay, let's not use a number then. X to the power of 3. Differentiate, then become 3x to the power of 2. Yeah. Oh, okay, I see what's wrong. This one is not. It's not plus, but it's minus. So this one is differentiation. Okay, so integration mean if a to the power of b to integrate, so that's mean a b plus 1 divided by b plus 1. Okay. Now if you came here and then I just straight you teach this, you may not understand everything happening. Okay, but I think it's very fundamental that you have to know integration to understand this. I have to know integration. I mean differentiation, because it came together. Like if you start learning, it's gonna be a bit hard because like everything is fragmented. Once you get the big picture, then it's gonna come to you. Okay, let's see the content. So first they do area under the curve. Yeah, this is integration, but integration came in two form. Yeah, this is where like people get confused. So integration came in two form. It's either gonna be area under the graph, or it's gonna be antiderivative. The method is the same, but there's some bit of different in here. Antiderivative is for differentiation, and this one is more for area and volume. Okay, I don't actually remember like how is it different. Yeah, but understanding like how is it different is like gonna go a long way in understanding integration and differentiation. Right, so let's go first one. Where is this? Opening problem. Function f x to the power of 2 plus 1 lie above x axis for x which is element of R. Thing to think about, how can we calculate the shaded area A, which is area under the graph, of 1 to 4? So what is function has x squared plus 1 that is derivative? Don't even understand what it's saying. Yo, who's Ryan? Which Ryan is this? But anyway, yo. Okay, I'm just starting actually. Like integration. I don't know if you like one of my students, you wouldn't know this is kind of extra stuff. But I think I spam level they do this, like Malaysian student. Okay, so I'm gonna have to find this area under the graph, but you see the graph here is like this. Troublemaker one, there's so many Ryan as troublemaker. I'm not sure which one. Thief Ryan, troublemaker. Chinese Ryan Wang, also troublemaker. Okay, so here if you know like area, right? You know the normal area that you do area like this. This one you can do because it's the first Thief Ryan. Oh, I see. Because this area is like polygon. Polygon area is easy. You just make a triangle and then you got square and triangle. But then when you have this kind of curve and then you want to find area under the graph, then now it's a problem because like we don't know this curve. This curve make it like complicated. So that's why we have this antiderivative, or we have the integration to do this. I'm not sure if it explains. So let's see if it explains this book. So this is a book like university student use, or at least the what do you call this? Is it Taylor? I think it's Taylor. Taylor used this maybe. What is this? Tan Sri something something. In this chapter, we consider integral calculus. It involves antiderivative, which is reverse process of differentiation. I already explained this thing. Finding area of shape, volume, distance. Oh, if it's first time, you're gonna get confused on these two. This one is fine. Okay, so let's see area. So the problem is area, right? This is what if you know, this is what the guy named Newton, Isaac Newton. In physics, Isaac Newton came up with this thing. So why he came up with this thing? Actually, he want to observe the moon. I think this part is like most people doesn't know. And then if you know moon, like move in a circle. Yeah. So starting to have a circular object and then something that is changed, like small changes over time. So the small changes over time make it like very hard. So here, the easiest one you want to find like small changes over time is the area. Okay, why is my pen doesn't work? Or maybe because it's this. I just want to wipe this name. Can you stop moving? Oh, okay. Okay, so we're gonna have to find area over time. So the thing is like the small changes. Integration is about small changes. So if you have this, there's no small changes. You have a straight line. It's fine. It's easy. But then now we have a curved line. So this curved line is where the problem came. So what people do to understand this, like small line, they're just gonna separate it up into a small boxes. So the small boxes come like this, like slowly increase. And then you got this area that you see. So that's why you see here. This is what they do. So they cut this up into smaller area. So what they do, they cut it up and then they make a small boxes. But then you might question that how is the area the same? Because you can see here, right, you want to find the area under this. Now we have a missing piece, like this thing. This thing is missing piece, right? How is it the area is correct when you have this area missing from your shape? So that's why you have to cut it more. Now we have to cut like even smaller. Instead of like this size, you're gonna have to cut like even smaller. Okay. So if it's small enough, like if the box is kind of small enough, then you have the change. Yes, now it's not obvious. The change is not too obvious now. Yeah, so this is what derivative, calculus or integration. Integration means you integrate this stuff, you combine it together, you cut this thing up, you make it small, and then you combine it together with just a small changes. So the small changes here is what make the area. So now we can find the area of the curve. Right, but that is just a concept. There's no math. But this is mathematics, so that means you have to go through the math. Okay, right now I'm just gonna read here. What does it say here? Lower and upper rectangle. Okay, area under the graph. The task is to finding area under the graph has been important to mathematicians for thousands of years. In the history of mathematics, it was fundamental to development of integral calculus. We therefore begin our study by calculating area under the graph using same method as the ancient mathematics. You say it's ancient mathematics, but it's just Newton and Leibniz. Newton and Leibniz like 500 years ago? 1,600? 1,000? Is it 1,800? Wait, maybe there's a more ancient than that. I don't know. Nope. Okay, let's see Newton. I know Newton created this thing. So Newton died in 1,600. So now we are 2020. So that's about 400 years ago. Crazy. Okay, but here say ancient mathematics. If ancient, I kind of like think about the ancient Greek, but they don't really do math, I guess. Okay, there's a lot I don't know about math yet. I know Pythagoras, that's Roman. That's also kind of ancient. We wish to estimate the area A enclosed by YFX. So we want to find this area. Let me remove all my drawing here. Let's see. Let's start from beginning. Why is it like this? Is my pen broken? Okay, let's start from beginning. Let's empty this nonsense. Okay, consider function f(x) x plus 1. So x square plus 1 is a quadratic, so you got a curved line like this, right? That is some quadratic equation, at least that much you know. Opening problem, we wish to estimate area A enclosed by y equal to fx. The x-axis and the vertical line x equal to 1 and x equal to 4. So x equal to 1 is here, x equal to 4 is here. So we want to find like this area. Okay, I suppose to divide interval 1 to x into 3 stripes with width 1 unit as shown. So they cut it up into 3 stripes. The diagram alongside show lower rectangle, so they find the rectangle below this line. So rectangle with the height equal to the minimum value of the curve on the sub-interval, the total area of the lower rectangle is fine. So here they find the lower rectangle. So they find 1 times fx, f1, right? So f equal to f1, so we got x squared plus 1, so that means this one is f1 equal to 1 square plus 1. So 1 square plus 1, this one is 2. So that means this area is 2. Right? So here is 1 times 2. So you got the area as 2 units square. Then the second one is just do this thing, right? So we find the 2 to 3, right? So that means 1 f to the power of 2, fx equal to 2. Then you put the value also, you got 2 square plus 1. So that means you're going to get 5. So that means this area is 5 and so on. So this area is 10. So plus this together, you get 17 units. So 17 units is only for this one. So to find this area, right? So this one is not accurate enough because we got a missing area, which is this part, and this part. So now I think where we're gonna have to use where we're gonna use integration. Okay, let's see next one. What do you do here? Okay, the next diagram show a rectangular, upper rectangular. Oh, okay, so the other one is lower and this time is upper, so it's both. Right, so total area of upper rectangular we got. So upper, that means we have to use this one. So lower we use this, where this one is equal to 2, right, f equal to 1. Now we use upper, so upper mean we have to use this one, and this one. So that means the first one is 5, the second one is 10, and then the last one is 17. Yeah, the last one is 17. So when you find the area, right, the closest we can find this area of this, it should be within this value, right? So the lower one is 17 unit square. The highest one is 32 unit square. Okay, so it should be like between this. So at least we know this much, right? But we don't know the accurate. So this is where we're gonna find the accurate value. Okay, now clearly that area is between the lower unit and upper unit. So this is what we have. So the area A lies between 70 unit and 32 unit. If the interval 1 x 1 to 4 was divided into 6 sub-interval, each of width half. Okay, so we divide this into now 6 sub-interval. So now instead of having 1 to 2, now they separate it more into half. So now where we're gonna make it like more smaller. Okay, it's kind of crazy, like if you know the history, like Newton figured this out during the what do you call this, a lockdown. They got a disease going on. This can happen like COVID-19 of the time. But in 6th century, okay, so now they make it half. So instead of 1, now we got 1 over 2. Then we got 2 1 over 2, and then we got 3 1 over 2 here. Okay, so now we make the box smaller. So what happens if we get the box smaller? Then we can do a smaller size. So we find again the upper limit and the lower limit. Right, so instead of using 1, now we use 1 and 1 over 2. So we use like this. So let's use lower limit. So lower limit will look like this, right? I kinda let's imagine if this is like accurate now. Okay, so lower limit, which is this one. So you're gonna use half of this function 1 over 2. Okay, each width is half. So that's mean the first half here is this one is the half, because you got f, we're gonna find the height, right? So f1, you should get the same as before. And then we're gonna have this thing, the second one, which is f1 1 over 2. Okay, so I think you can put calculator here, but we kinda have to skip this one, I think. Right, so this one is the same number as before, which is, I remember, is 2. And then this one 1 over 2. But then we time half here because this is the width, right? So we want to find the area. So now the area of the box look like this. So this size is 1 over 2 and this size is 1. So you got here, but then you have to times 1 over 2. That's why we have this. Right. Then we continue with this one. Alright, this one is what we have here. Then you continue with this one, the second one, and so on. I'm not sure if I skipped too much, but if you cannot follow, it's fine. Right, I'm not sure if the other side still exists, but it's fine. Just me learning. Okay, but I understand this much. Okay. Okay, so we get this value, half of this. But then since everything is half, it seems that the equation here, they extract this one, they factorize this, so we don't have to deal with the divide every time. So you can divide it all at one. 13 over 4. Okay, I think you can try at least get this one. So if you got f, okay, I don't want to use fraction. I think it's easier to change this into this fraction. 2 plus 1, 2 plus 1 is 3, so you got f 3 over 2. So given that our equation again is x squared plus 1, so you got 3 over 2 square plus 1. Okay, so 3 is 9, 2 is 4, plus 1, so that means this 4 over 4, 9 plus 4 is 13 over 4. Okay, so which is, we got this number. Right, so the rest should be the same. So you're gonna get 5, 29, 4, and then we plus everything, so the lower unit is 27.875. Right, and then the upper unit is 20.35. So what's the point of doing all this? Right? What's the point of doing this? So the point here is actually refinement. So as you compare, if you compare this one got a lot of empty space, right? So if you do lower limit and then you do upper limit, you're gonna get something like this. Right. So the difference is huge, but by having it like very much smaller, so when you change it into smaller, you're gonna get like a small differences. So here this is the lower limit, and the upper limit is here. Here, 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 and here. Right, so you see the difference is very much smaller. And then when you do like cut it even more, so you're gonna find that the difference become much smaller. So why this smaller difference is so important, right? It's important because you increase the accuracy. Right, so we are increasing the accuracy of this mathematics. So instead of having 17 to 32 unit, right, 17 unit, like the area could be between 70 units to 32 units. Now we got it smaller between 20 to 27, which is much more accurate. Right, but this is when we cut just by half. And then if you cut more, then you're gonna get like even more accurate number here. So I believe this one would be lower than 20. I don't know, could be 18 here. And this one would be lower than 27, I guess. Could be okay, what is lower than 27? Oh, this one not gonna be lower, this one gonna be higher, my bad. Because we're getting like smaller in the range. So this one will probably like 24. This one probably got 25. Yeah, I think that's logical. So probably the answer is 24.5 or something. Okay, but we doesn't know that yet. Yeah. Oh, how do I go? Oops. Okay, but we doesn't know that yet. Right. So the only thing we know here, if we cut it smaller, it become like very much more accurate. Right, so that's the point. So from this refinement, we conclude that the area lies between 20.37 unit to 27.87 unit. As we create more sub-interval and the estimate AL and AU will become more and more accurate. In fact, the sub-interval width is reduced further and further. Both AL and AU is converged into A. So A is what we want. So area is the most accurate answer, which is the correct area. So this is what we do, right? So this one is lower limit, area lower limit is area upper limit. So you're gonna cut it like smaller to smaller. So this one until you got like the most accurate, which is A on this one. Right. So we illustrate this by process by considering another example. This time at estimating the area A between the graph y equal to x square and the x-axis of 0 and 1. Okay, now they give us like a new example. I think it's smaller. So they got y equal to x square and then between 0 and 1. So they try to find this area. So what is this area, right? 0, 1. Okay, so they do the same thing again. So this example is of historical interest. Archimedes. Actually, Archimedes do this. Oh, okay, I never knew that. That's crazy. Did I say Archimedes? I don't think I said Archimedes. I did say Roman. Okay, but Archimedes is Roman. He's a Roman mathematician who like very much interested in like circle and stuff. But I never knew that he do this. That's crazy. Right, so find the exact area. In an article that contained 24 propositions, he developed an essential theory for what is now known as integral calculus. He developed it. He developed essential theory. 24 proposition. Alright, okay, there's something new. I always thought Einstein did this. Okay, that's crazy. Okay, I got a huge respect for Archimedes. Archimedes calculus. Actually, he actually did that. Integral calculus. His great invention was integral calculus to determine the area of section bound by geometric figures such as parabola and ellipses. Archimedes broke the section into an infinite number rectangle and added the area together. This is known as integration. Oh, that's crazy. He actually did it like much earlier than Newton. And Archimedes is one of the Roman architect. And I think he lived like a lot longer. It's 287 BC. So that's like 800 years. Is it 800 years? It's like 800 years before Newton. That's crazy. Okay. Yeah, that's crazy actually. Wait, I want to see Newton. What Newton actually did. Newton contribution to calculus. Okay, generalized binomial theorem, theory of finite differences, fractal exponent, coordinate geometry, Newton method of finding function roots. Okay, infinite power series. Oh, actually, so the basic thing is of calculus already done like way earlier than I thought. Okay, I thought I knew mathematics, but actually I didn't know much. Okay, that's crazy. He developed essential theory of the integral calculus. Alright. Go f(x) to the power of 2 divided by integral 0 to 1 into 4 sub interval of equal. So we got these. So this one is for 1. So the lower boundary is 0.219 area and the upper boundary is 0.49. Okay, actually understanding this is so important to understand what is integration actually is. So now suppose there are n sub-interval between x and 0. Okay, so now we are changed. This is where people got problem, you know. Like if it's just number, like people got no problem in doing number. But then when we put like n and stuff, then people get confused. Okay, I might get confused also. Okay, let's see 0, 0, 1. Okay, we start this one. Now suppose that there are n sub-intervals. So now we got n. So n mean like how many number that we are cutting. I think so. Maybe I'm wrong. Don't know. Now suppose there's a n sub-interval between x and 0 and x equal to 1, which is with 1 over n. We can use the area finder software of our graphic. I don't want to use any graphic. Where is this? Where can I find this? I don't know. Alright, that's fine. The table alongside summarize the result you should obtain for n equal to 4, 10, 25, and 50. Right, so n is subinterval, so subinterval between 0 and 1. So each width is 1 over n. So if 1 is equal to 1, so I mean the whole thing is just one value. So I think this one is 1 over 3 because we divide this by 3. So here we got an answer if the division is divided by 4. So the area is divided by 4. So like 4 you got this area, and then you divide it 1, 2, 3, 1, 2, 3, 4 like this. And then 10, I mean you divide this thing to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I couldn't even put in my marker. And 25 is a lot more. And 50 basically like infinite number. Almost infinite in terms of this. Okay, but the point here, the upper value, the lower value and upper value, you got between 0.2 0.4. But the higher number you get here, then much closer the number. So the average here is the area. So this one is lower down. And then at here it doesn't lower down much. You can do 100 here, but it doesn't change much here. You're gonna get same value here. So probably the area here is 0.33. Okay, so the table alongside summarize the result you should obtain for n equal to 4, 10, 25, and 50. The exact value of a is in fact 1 over 3. So 1 over 3, if you divide, you're gonna get 0.3333 and so on. As you will find later in chapter, which chapter? I don't know which chapter is missing. How both lower area and upper area converge to this value as n increase. Right? Okay, that's very interesting. See what kind of question we have here. Okay, consider the area between y and x axis from x equal to 0 x equal to 1. Divide the interval into 5 sub-interval of equal width, then estimate the area using lower rectangle. Oh, they want us to do this. Y equal to x. Y equal to x is not even a quadratic function. It's not even a curve. It's a straight line. And then here 0 to 1. So alright, let's okay, let's do this. Divide by 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. 10 divided by 5, you get 0.2. So let's move this 0.2, 0.4, 0.6, 0.8, and 1. But it doesn't matter because the width is always constant. Width is 0.2. Okay, so estimate the area of the lower triangle. So lower triangle, this one is 0, right? Second one is this. Third one is this. Fourth one is this. Fifth one is this. So this one is 0. So we got like a 4 rectangle. So now we're gonna have to find the height. So example, if the y here is 0.4, that means the height here is also same because y equal to x. So this one is 0.4, this one is 0. Okay, this one is 0.4, this one is 0.2. Okay, my bad. Let's change that. Okay, so here is 0.2, here is 0.4, here is 0.6, here is 0.8. Okay, so the width is 0.2. So we're gonna get equal here. So 0.2 times 0.2. Okay, 0.2 is 2 over 10 times 2 over 10. That means you're gonna get 4 over 100, which is 0.04. Okay, I don't have space to write. I need a smaller marker. Boom, smaller marker. Okay, 0.2, 0. Okay, this one is 0.4. Where should I put? I don't have space. Okay, 0.4 plus 0.4 times 0.2. So 4 times 2 is 8, so that means plus 0.08. Okay, next one is 6, so that means plus 0.12. And next one is 0.8, which is times 0.2, we get 0.16. So plus this all together. I think I can just use my calculator. So 0.04 plus 0.08 plus 0.12, 0.16. So I should get here actually 0 0.4. 0 0.4 or 1/5, right? Or 2/5, my bad. Okay, so upper rectangle. Now we're gonna have to use this. Okay, maybe this. Not sure why the marker never like this before. Oh, okay. So this one I'm gonna use upper limit, which is this. So this one is 0 0.2, 0 0.4, 0 0.6, 0 0.8, and this one is 1.0. So 0 0.2 times 0 0.2. So that means this time around we're gonna get like extra. Okay, so first one is 0 0.4. It's the same as this. Second one is this, but the third one is the fifth one is where it's different. So you got 1.0 times 0 0.2. So 1.0 times 0 0.2, that means we have to plus 0 0.2 here. So that means this one is 0 0.6. Alright, so upper limit and lower limit is between 0 0.4 to 0 0.2. Okay, calculate the actual area and compare it with your answer in A. Oh, that's kind of smart. Alright, so actual area is actually it's just a triangle. Alright, it's a 90-degree triangle. So this one is 1 times 1. So you should get 1 times 1. Oh. But because it's a triangle, so we have to divide it by 2. 1 times 1 times 1 over 2. So that means we should get 0 0.5. So the answer here is between 0.5 and 0.6 between that. Alright. Maybe this one, this question is just to show you like how this thing works. Even though it's not a curved line, right? So mathematics should converge. Right? The concept should converge and like support each other. So if you can find area in a curved line, that means the same method. Like we use this method of integration. That means we can use the same method to find this triangle. So that's what it's trying to do here. Right? So this is a complementary of mathematics. It should work like this. Okay. Consider the area between y equal to 1 over x. So y equal to 1 over x, you're going to get a, what do you call this? I forgot. Inverse graph. X is this. So we're going to have to find from x is equal to 2 to x is equal to 4. Divide the interval into 6. So that means we have to divide this into 6 parts. 1, 2, 3, 4, 5, 6. Okay, so that means the difference here, the range here is 2. So 2 divided by 6, you got 1 over 3 or 0.333. So that means the width here is equal to 0.333, or you can use like 1 over 3. Okay, then estimate the area using lower limit and upper limit. Okay, so that's why we have to do it again. So here our equation here is y equal to 1 over x. So now we have to find this x. Example x when is equal to 2. Right, so x when is equal to 2, y when is equal to 2, so that means 1 divided by 2. So the first one is 0.5. Right, so this one is 0.5. And then we have to plus this 0.33, right? 2.3 times with, okay, what do we have here? 1 divided by answer. So 1 divided by 2.33. Then you get 0.2429. Okay, this one I'm gonna get a bit complicated. Okay, and then we have to plus another 3, that may become 2.66. Then this one is 0.37. Okay, We need how many more? We need like 3 more. And then we plus another 3, so that means 2.99. So we're gonna get about 0.33. 334. Then we're gonna plus another 3. So 0.99 plus 0.33. Let me put a bracket over here. 0.3. Okay, 0.301. How many we have? 1, 2, 3, 4, 5. Okay, that means we need one more. So plus another 0.33. Okay, so we got 0.270. 2.273. We're getting complicated now. Now we find the width. So the width is constant, which is 0.3. Okay, so that means we have to times this. We have to times 0.33 times whatever number that we have here, the y. So first one is 0.5. Okay, you know what? I'm gonna do everything in calculator. So if you didn't follow, you might get lost here. Okay, 0.5 plus 0.33 times with 0.429 0.33 times with 0.372 plus 0.33 times with 0.334 plus with 0.33 times with 0.301 plus 0.33 times with 0.272. So here what we're gonna get? I'm gonna get 0.735. Okay, so now for upper, did I do upper or did I do lower? Actually, I think I do the upper one for this, because the lower one is the opposite. 1, 2, yeah, I think this one is for upper. Because it go like, okay, how do I explain this? Okay, it goes here, like this. So if it lower should be this one. Yeah, so lower should start here from 0.4 until here. What is the lowest one here? Okay, upper is this one, lower is this 1, 2. Oh, okay. So that means we have to find the one on the 4. So 4 here. Okay, I didn't do it. Okay, let me try to do it. So 1 divided by 4, we should get 0.25. Okay, so the last one I didn't do. So the next one we have to do lower, which is we have to start 0.49 to 0.25. Okay, we're gonna use 0.5 here. 429 times with 0.32. Oh, actually, why I'm so dumb? I can just factorize 0.33 and then plus everything inside. God damn, I'm so dumb. I should have figured that out earlier. Actually, I should have figured that out. What am I doing with my life? Wasting so many precious time. Okay, alright. So this one is actually low limit. So this one I'm gonna get 0.652. So the area should be inside here. Use rectangular to find the lower. Oh, this is a different question already. Okay, shall I continue this one? Okay, if I already understand, I don't think I want to continue this one. Okay, use rectangular to find the lower limit and upper sum for the area between the graph of y equal to x squared and the x-axis for lower than recommendation. It's fine. I don't care about the stream as much. Okay, y equal to x squared and the x-axis 1, x2. Use n equal to 10, 25, 50, 100 and 500. Give your answer in 4 decimal places. As n get larger, both converge to the same rational number. What is it? Okay. Give your answer in 4 decimal point. Okay, they wanna. Oh, that's a bit too much here. We wanna use one n equal to 1/10. Okay, so that's mean we have to find the width. So our number here is from 1 to 10, 1 to 2. So that's mean the total width of the thing is actually 1, right? Because you got 1 to 2, so the width, the total width is equal to 1. But then when we divide it by 10, that means we divide everything by 10, so we have 1 divided by 10. So this is the width. So what we have to plus, okay, I'm trying to make the equation here. So what we have to find is we have to plus this, x squared, right? We have to plus y for each x squared. Okay. Do I make equation here? Is that what it want us to do? Rectangular to find the lower limit. I think it should have the equation. Do I need a whiteboard? I think I need a whiteboard. Okay, let's get a whiteboard. Whoa, it forced me to derive. Feel good to do this thing because I used to like mathematics like so much, and like doing mathematics at your own free time, that's crazy. It's not even free time, it's my sleeping time, 1:43, and I spend to do mathematics. I could be playing games, but I feel like I'm gonna do math today. Okay, something like your brain just function in the middle of the night, so like it feels good, but it's kind of lonely. Maybe that's why I'm streaming. I don't know. Human is like a weird need for validation, I guess. Okay, so the question is, so we got the value is from, our range is from 1x to 2, right? And then the n, the division, is it called division? Wait, it's not division, it's what is it called just now? Interval. Sub-interval, okay. Right, sub-interval, we got 5, 10, 5, 10, 50. Oh, not this one. This one, 10, 25, 50. Okay. So 10, 25, 50, 100 and 500. Yeah, so given that our equation is y equal to x squared, this is our equation, y equal to x squared. So we want to find every here, right? So you see, this one we're going to have to do with, right? And then we're going to have to do f equal to 1. Yeah, I think it's like that. But here it's not equal to 1. So let's example, we got n equal to 10. So that's mean the first one is f 1/10, correct? Yeah, so first one here is f times 1/10, and then we're gonna have to plot the width, and then f. Okay, the first one is 1/10. That means the second one is 2/10. Okay, and then the third one is width times f 3/10. Okay, but we don't want to do like this, right? This is a bad way to do mathematics because you are like, how do I say? You are like doing this manual. So what we're gonna do? We're gonna have to. I think we're gonna have to find an equation to explain all this. So you see like how width is repetition. So I'm gonna factorize that out. So we got width on the outside, and now we left with f 1/10 plus f 2/10 plus f 3/10. Oh. Okay, and so on. But then this thing is also repetitive, so we don't want to use this. We want to use n. So that's mean gonna have width of f n/10. And then plus f. Think, is it n plus 1 here? No. I think it's wrong. So now we're gonna do f plus f and 2n. The second one is here, where n is equal to 1, 2, 3. Oh, okay, I know. It's not like this. You don't do the equation like this. We have to put this thing. Okay, let me move this first. Comp. You go to the front, and let's put this, and then we have to sum it all. We have to sum everything here. Sum everything. Right, sum f for all the n. So that means start with 1, 2, 3. Okay. I think this looks good. But w here shouldn't be w because then it can't be w, right? Because this is our w. But here, okay, this is getting confusing. Okay, this one is width actually. So like, let's put this as width. It's not width also, because width is 1 over 10. Here, width is 1 over 10. Okay. This is not width. This is sub. What do you call that just now? I forget. Sub interval. Okay, this is sub interval. I don't want to get confused. As okay, so this one is sub interval, denoted by n. Okay, with fn divided by 10 and 1, 2, 3. Okay, does it solve the equation? So the equation is x to the power of square. So that means this thing is x. So n. So if we open this up, you're gonna get f. The function is x squared, so this one will become x. I'm gonna input is n to the power of 10. So n over 10 square times with our width. So our width here is 1 over 10, which is n is here. The width is 10, so we put here. Okay, so n is 1, 2, 3, and here is stop until 10. So that means this one is also, it cannot be n, because this is the final one. This is the n term. Okay, I don't know what to put there, but let's just put 10. Okay, so here we break it up. You got 1 over 10 times with. So the first one will be 1 over 10 square, plus the second one will be 2 over 10 square. So I think this should be correct. Okay, so we're gonna repeat this until 10 actually. Okay, so 3 power of 10 square and 4 power of 10 square, and okay, so that's what we have to do for n to the power of 10. But how we do the sum of sequence? I forget this. Sum of a sequence. Maybe I'm cooking way too much here. Okay, to do sum of a square, we have to use this equation. N is the number of term, Sn is the total number of a sum. Because when I find the area, right? Dude, I might just derive the integration. But we see, I don't know. Yeah, I'm crazy. I'm cooking. God damn. Shouldn't be this hard. This is just introduction. Yeah, I might do way too much here. Okay, so n is the n term. Let me write this down. Real quick. And put dot. Yeah, I'm having fun. N to the power of 2. A is the first term, right? A is first term plus L is the n term. Number of term. What is the n term? how do I know anthem? Oh. Oh, that's when I have to find the anthem, which is the one with the number 10. Okay, I think we can do that. Okay, this one is the anthem. Okay, I already know A is anthem. Okay, alright, let's try to do this. So our n is 10 divided by 2. Okay, we're just gonna do the inside one. So our first term is 1 over 10. Do we have to square? I think we have to square here. Yeah. Plus, the final term is 10 divided by 10. Is it 2? Yeah, because it's gonna be 1, right? It's gonna be 1. Because our range is from 1 to 2. So yeah, it should be 1 because we're counting the width. Is it 2? Okay, I'm confused. Could it be 1? No, it couldn't be 1. Okay, if you see the range of y, right? Y is goes from 1 to 4. Yeah, y equal to 2 square, which is got 4. So the range is from 1 to 4. So that's mean is the final answer shouldn't be 10 over 20. Okay. Right, so you see here it start from it start 2, right, 1 to 2. So this have to be 1 over 10 times 2. And then the last one will be 10 over 10 times 2. Yeah, that's the correct one. So that's mean we have to times 2 also here. Okay, am I getting crazy? Oh yeah. Yeah, here. Inside here should have 2. So that's mean we're gonna have to put 2n here. Do we have to square the 2? Yeah, we definitely have to square the 2. Okay, so if we fix this, yeah. So it should be 2n over 10. Okay, yeah, I think that makes sense. Okay, alright, so to fix that, so 10, so our first term will be 2 to the power of 10. Oh god damn, I'm going crazy doing math in the middle of the night, almost 2 in the morning. Okay, so that's mean the final term should be 20 because 2 times 10 is 20. So 20 over 10 square, this is our final term, and then we have to times this. Okay, let's see if we cook or we burn this whole thing. So this one will be 5. 2 square is 4, so plus 4 over 100 plus 20. This one will be 2 times 2 is 4. This one will be 400 over 100, I think. 20 times 20, correct? 0, 0, 0, 4. Yeah, 400 over 100. So we plus this, you're gonna get 5 times 404 over 100. So divide this by this one become 100 divided by 5, you got 20. So can we divide this? So that means this one become let's divide by 2. So you got 202 over 10. So divide by 10, so that means we're gonna get 20.2. Oh, that's crazy. Okay, so 20.2 is just the total length, right? So because we didn't do this one yet, so that's mean 1 over 10 times is 20.2. So you should get here, this one should be 2.02. Okay, so wait, okay, I already lost what I would do. I think this one is a lower limit. This is a lower limit. Okay, we just do we just do 10. We need to do like 25 and 50. But I think the next one it should be easy because we just changed the end. Okay, let's I need to go deep here. I need to go deep. I need to go deep and find if this is correct one. Alright. Okay, let's go deep. So what is our shape here? Oh, it's x square. Okay. So we got graph over y equal to x square. So this graph will mean I think gonna look like this. This one start at 0. This 0 0 1 1. So 1 here, 1 here, 2 here, 2 here will be 4. So my scale is inaccurate. I think I should just use that small size this one. This one, this one. Oh, it's raining. Small graph calculator. Hey, what's the graph calculator? Give me graph calculator. Okay, y equal to x to the power of 2. Yeah, exactly. Exactly, we're gonna get this kind of graph. Okay, but the thing here, okay, we wanna find like between 1 and 2. So all this thing doesn't matter, right? All the other number doesn't matter. We're just gonna look at 1 and 2. So 2 will be here. 1 gonna be here. Let's ignore the scale. Scale not important. Okay, 1 to 2. Right, and then we're gonna cut this part by 10. Right, so 1, 2, 3, 4. Oh, let's use the scale. Okay, now scale become important again. So this here is 2. So 1, 2, 3, 4, 5, 6, 7, 8. Why is it only 8? What kind of scale is this? We should have 10 scale. 1, 2, 3, 4, 5. Oh, okay, let's fix this. So here is the middle point. So that's 1, 2, 3, 4, 5. Here should be 2. Okay, another one. Oh. Okay, I think I can make it like this now. Is it like this? Oh yeah. Oh, look at that. Yes, can draw a straight line. So 1, 2, 3, 4, 5. So this one is 1. So this one is 1.5. Okay, so each of this is gonna be 0.1 increment. Right, so that's the width. 1 over 10 is 0.1. So this is the width. Right, so we're gonna have to find this, each of this, because I'm trying to prove my equation right now. Okay, so we're gonna have to find one of these. So that's mean y equal to x square, right? So example, if I'm gonna find this one, 1.1, so I'm gonna have to put what is the y value? So y equal to 1.1 square. Example, if it 1 will be equal to, actually 1 will be equal to 1. So here is 1. Okay, I'm gonna use calculator right here. So 1.1 square, which is 1.21. The 1.2 square, 1.44. I don't have space to write all of this. 1.21, 1.44. Okay, 3, 1.69. Okay, let's do 4. 1.96. Dude, we didn't even start actual calculus yet. That's crazy. I never done this in university because we skipped so many stuff, even in school. Actually, but this thing like give me a lot of understanding. Maybe some of our understanding that I'm missing also. Kinda great. 2.89. To know, like, actually start, like, Archimedes is one of the people who do this. It's kind of crazy. Okay, world is rich. The world history is so rich. We are focusing on, like, a very shallow aspect of life. 3.61. And then last one is 2.0, which is we're gonna get 4 over here. Right. So this is the height. We got the height. Now we're gonna have to find the area. So I think what I'm done here is the lower limit. I think. I'm not sure, is it lower limit or upper limit, because we start at 1.0. So that's mean we didn't start at 1. So this is upper limit. 2.20 is upper limit. So let's try to find the upper limit. So that's mean we're gonna have to 1 over 10 plus every number that we have here, which is 1.21 plus 1.44 until number 4. Okay, so I'm gonna do that in my calculator over here. 1.21 plus 1.44 plus 1.69 plus 2.26, is it 1.44 minus 69? Oh, we got 1.96 there. I'm not sure it's 6 or 8, but let's hope the error is small. Okay, well, that's fine. We are doing a lot of approximation with this. 2.56, 2.89, 3.24 plus 3.61, and the last one plus 4. Oh, close the bracket. Right, so we got about 2.48, and that is I think quite far from our answer here. Maybe this is a lower bracket. Yeah, maybe I don't know. Yeah, oh yeah, I think it's a lower one. Okay, let's try to get the lower one. So this is our upper bracket, the area upper, and we're gonna try to get area lower. So area lower, we just remove 4, then we just plus 1 at the end, I guess. Yes, so lower limit you should get 2.18. Okay, okay. Okay, you know what this means? This means my equation is correct, but I have to know, like, what I'm doing. Am I doing the lower limit or I'm doing the upper limit? So for upper limits, yeah, this one is lower limit because I supposedly start at 1, because 1 times 2 here. So if I want to do upper limit, I'm gonna have to do I'm gonna have to start at 2, I think. 2 times 2. Okay, so lower limit, it goes from 1 to oh yeah, this is low limit. So low limit, it goes from 1 to 10. So that's mean upper limit is go from 2 to 11. Should be right. Okay, so I'm gonna have to make, like, equation for this. So we don't have to calculate so many times, like again and again, this thing, right? This is interesting about mathematics. Okay, so we have to put this in the equation. So we know our width is 1 over 10, right? So we're gonna have to put this. So that means this one is n over 2 time with so our first term will be because we are doing 2, and our first term is 1 times 1 out of what is our width, right? So we're gonna have to put width here plus with our final term. So our final term is 2 divide by, so how do I get the final term? The final term, example, if the width is 10, right? So our final term is 10. So that means our final term is w also here, and then this one divide by width also, and this one is 1 over So I guess this is actually the whole equation. Okay, so we're gonna have to try this to prove it. Is it correct? So W here is 10, right? W is equal to 10. That's mean, what is N here? N is the number of term. This one is also can be put as W, I think. Or is it just N actually? We don't need for W. Kinda dumb. Alright, so that's mean this is N, and this is N. Okay, I might be wrong. Something need to fix. Okay, so if N is equal to 10, so that's mean we got 1 over 10. 10 divided by 2. 2 times 1. Divide by 10. Plus 2 times 10. Divide also by 10. Let's see if we can get the answer. Whatever I'm doing here. Okay, at this point it looks like complicated. It's like stuff of magics. But it's actually not. It's you kind of have to understand like one by one. But I cannot say anything unless I prove this is correct. Right now this is still might be wrong. Because I might messed up somewhere. Okay, let's close all the bracket. Then we get. Ah, okay, I got it wrong. Actually, I got it wrong. Okay, what did I do mistake here? Oh, because we didn't square. Our equation got square. I forgot that. Alright, let's put a square here. And the square here, I guess. Okay, so that's mean we have a square here and square here. Okay, now let's try this again. Okay, so to get the square I need to put bracket inside my calculator. Square here. And I'm actually cooking this stuff. Oh, that's correct. Okay, that's interesting. Okay, let's see. Oh, syntax error. What did I do wrong? Okay, I got square here. Do I miss any other square? Oh, yeah. I missed another bracket over here. Okay. Alright, that's cool. Alright, so I did this. Put a square. Now I got 2.02. Which is, we get what we actually try to find. Which is this thing. So we got the lower limit. Right? So to get the upper limit, that means we need to change here. Because we have to plus 1. So lower limit is n. Right? First term until n. The upper limit is second term until n plus 1. So given that our n is 10, so now we have to do this one. We have to do second term, which is instead of 1 we put 2 here, and this one is the n plus 1. So our n is 10, so we're gonna do 11 over here. Alright, so if we do this, we're gonna get the upper term. So this is let's put this aside. Dude, this is actually feeling so good. Okay, this is our lower term. Let's find our upper term now. Okay, so we do the same equation except we change the number. Okay, this is why people do math, because it just feels so good when you figure stuff out. Alright, so here upper limit you get 2.5, which is, if we look at this, right, you look at this is 2.48. This is quite close. So okay, so now we got the equation. So our equation is done. That's mean we don't have to do all this thing again. So I spend like 30 minutes do this, so I can get this thing like general term. Right, this is our general term. Now we can just use this. Right, that's crazy. Okay, let's put a table now. Let's try find all the answer. We put a table. So this is our n, number of term when term is 10, and then this is the area for lower, and then this area for upper. Alright, so when we get 10, our lower is 2.2, and our upper is 2.5. Okay, now we're gonna use for next one. So next one is 25. So you know what we need to change now? Like, this is crazy. We just have to change this. 25. We put this 25. Right, then we change this. N is equal to 25 now. So we just take this and then we do the first term. So for n equal to 25, you see this is 1 over n, so that means this is 1 over 25, and then this one is 25n divided by 2, right? And then we have another bracket inside here, right? So this is 2 on the first term, which is 1, divide by n, so our n is 25, and then we have to close the bracket and square, right? And then next one is we put this 2, but then now it's n term, so that means it's 25, divide by 25, close bracket for the square, and then we close our big bracket. So do we need this bracket actually? I don't think we need this bracket. Let's remove that. Okay, so this one is our lower limit. So let's try find this. Why am I doing this? Okay, let's go. 1 over 25, and then put bracket. Dude, I want to do this like harder stuff, you know. It just feel, I couldn't explain to you how this feel rewarding if you don't like to do mathematics. Yeah, it's kind of hard to explain that. Like, how is it rewarding to do math? It's like you have to do work, no one paying you anything to do this. And how is this rewarding? I don't know. You just have to do like math and physics and find it yourself, maybe. Okay, close the bracket, and then we should get, yes, now I don't have to do much of anything. Alright, so our lower limit now is 2.00, 2.0032. Okay, now we're gonna have to find the upper limit. So upper limit we have to plus 1, so that means we change the 25, the last term, to 26, and then our first term will be the second. So put 2 there, then we got 2.17, so here become 2.17. Now we are closest to the truth, right? So from 2 to 2.5, now 2 to 2.17. Okay, now we're gonna do 50. Okay, now everything become easy, you see. That's why I spend so much time do this equation. So now we change n equal to 100 now. Dude, I feel like crazy talking in the middle of the night, like a single person talking alone in the middle of the night. That's crazy. Doing mathematics in the middle of the night. Am I going crazy? I don't know. Nah, just for the fun. So this one I got 2.0002. Right, so for upper limit we have to again plus 1. Should be plus 1, right? I think so. Shouldn't be like plus 10. That does not make any sense. Okay, so here you got 2.041. So I'm pretty sure the answer is 2. Okay, so we do 250, 100 and 500. So we have to do 100 and then another one for 500. Okay, so you got the equation, it becomes so easy. I don't even have to take now because I already done the thinking process. Now I just write down, like put in calculator is software. 500 now. Oh yeah, I skipped 100. Okay, that's fine. Oh, did I do 100 just now? Maybe I mistake it with 50. That's fine. Let's just put 500 and then we're done with it. Alright, so lower limit for 500 is 2.000012345 Okay, upper limit will be 501 and 2 over here. Yeah, so I got 2.00804. Okay, so that means the answer is actually 2. No way, the answer is like beyond that. Alright, done, we're done. Okay, let's see. We have to. There more. Okay. Give your answer into 4 decimal place. Okay, that means just change this to decimal place. That's fine. Doesn't have to do that. As n get larger, both al and au converge the same rational number. What is it? So the rational number is 2. That's all. We got here 2.0008 and 2.00804. So let's mean the answer here is 2. Okay, do we need to do this one? Let's see. Lower and upper rectangular sum to estimate the area between the following function. 0, x1, use 5, 10, 50, 100, 500, 1000, 10,000. I don't think we have to do this because we already done this. We just change this. Like example, if we see this x to the power of 3, so that means here you change inside here to x to the power of 3. So here instead of power 2, you put power 3. That's it. But do we need 2 here? That's 2 depend on the range. So since the range is from 0 to 1, so we just alter this equation. We remove the 2. Because the range start from 0 to 1. Okay, so we don't need to do this. Because I pretty much understand this already. Okay, if it y equal to x, so that means we don't have to put the power. Okay, I'm just going to write down the equation for all of this. That's the equation. So for y equal to x to the power of 3, that means it's going to be 1 over n times with 1 over n times with n divided by 2. And then we do the first half, which is because we start at 0 to 1, so that means we don't need 2 here, so we just put the first term divided by n, and then we don't need power because this is power 3, so power 3 you have to put like power 3 here, and then plus the final term, which is n divided by n to the power of 3, and that's it. Yeah, that's all we need. So if it y equal to x, now we change it, the equation to 1 over n divided by 2, and then a whole big bracket over here, 1 over n, and then we don't even need the power, n over n. That's it. And then if it 1 over 2, again same thing, 1 over n over 2, big bracket, smaller bracket, 1 over n, 1 over 2, plus n over n, 1 over 2, close the whole bracket. Oh. Okay, we're done. I think we're done. Okay, I already understand this enough to move on. Alright, AL, AU, we don't have to do this. I'm pretty sure it's going to be the same thing. Using your answer to be, predict the area between the graph of y, x to the power of a. Okay, maybe we do this. See. Predict the area between the graph y equal to x to the power of a, where the area. So this is what we're trying to find here is the area. Right, this is the area. So if we're gonna predict this from 0 to 1, and any number a that is larger than 0. So that's mean we do 1 over n. Do we put n here? Yeah, actually, yeah. So this one times with, I think I have to put bracket here. N over 2, then like big bracket, smaller bracket, 1 over n to the power of a, plus n over n to the power of a. Close the big bracket, close the smaller bracket. That's it. Okay, what else can we do? Yeah, I'm pretty sure that's it. 1 to the power of a is 1 because 1 to the power of whatever number is. No, I don't think it works like that. Yeah, n over n is 1, so that means it's 1 to the power of a. 1 to the power of 2 is 1. 1 to the power of, can we get 1 to the power of 0 0.5? I think it should be the same number. Yeah, 1 power anything is 1, so that's means we can solve this more, right? So this one is 1 because n plus n, so that's mean if we're gonna solve this, so that's mean this one gonna be 1, whatever plus a is 1, so this one we left with this 1 over n to the power of a, and then because 1 to the power of a is still 1, so that's mean you're left with this 1 to the power of n to the power of a, right? And then here we got this one covered because 1 n times n, so that's mean you're left with 1 over 2. So is this the answer? A is equal to 1 over 2, 1 over n to the power of a plus 1. Actually, we can try. I'm gonna try this equation on this thing because I didn't figure this out. Alright, so if we use this, right, so that's mean it's gonna be 1 over 2, 1 over 2, which is, because this one got 2, so I'm gonna put there here. So this one is 25 to the power of 2, this one is just plus 1, that's it. Okay, are we gonna get the same number? I think so. There it is. Crazy. Okay, kind of crazy that I'm still learning like so many new stuff. Oh yeah, I might do something wrong over here. Oh yeah, because this thing is not 1, this thing is 2, because you have to times 2 here. 2 times 1, so you have to plus 2. So by plusing 2 here, then we get the, I think we get the actual answer. .1006. No, we don't get the answer. Did I do mistake somewhere? Oh yeah, I know. Okay, because this one is square, so that means we have to square this. Oh. Okay, so we do get 2.016, which is close to the answer. This changed because the scale changed. Unless the scale haven't changed, then it would agree to this one. Okay, that's kind of interesting. And we spent how many hours just to 4 pages? Okay, let's try another question. No, I don't know where I'm gonna sleep. This thing is getting interesting. Maybe I sleep when I'm tired. Right, consider the quarter circle with center 0.0, and the radius unit illustrate. 2. Its area is 1 over 4. Full circle is 2 radius. Okay, understandable. 2 pi times 2 square. 1 over 4 pi r square because the radius is r. Then you got pi. So this is the answer is pi. Estimate the area using lower and upper rectangle for n equal to 10, 50, 100, and 200. Okay, so the curve here is this thing. Oh yeah, because this is a circle, I think. Because y square plus x square equal to 4. This is an equation of circle. So they put us onto equation of circle. Ah yeah, here you see x square plus y square equal to the radius. So the radius is 2. So that's what we have over here. Okay, what we're gonna try to find, we're gonna try to find the area, and then you're gonna see like if the area push pi or no. Yeah, I think that's what they're gonna do. Right, so that's mean y is equal to square root pi minus x square radius square. Okay, I understand that. Okay, so now we're gonna have to do this for. Okay, so our graph look like this. This one is 2. This one is also 2. Okay, should I use my equation then? I think we should, because I already make the equation. Why is it 4 if I'm not gonna use it? Okay, so they want us to do for 10. 10, 50, 100, 200 and 1000. I'm just gonna write now. 10, 10, 50, 100, 200, 1000. And 10,000. What do we need 10,000 for? I don't think we're gonna reach 10,000. We're gonna get the answer before that. Okay, find the rational bound for pi. Is this how they found pi? That would be crazy also. Okay, let's use the equation. So our equation we got equation that I came out with 1 over n okay, times this n over 2. Okay, so our scale here is between 0 to 2, so it's not 0 to 1 anymore. Okay, how do we change this? I think we have to change the width. Because we got a 2 now. Just now I do like from 1 to 2. Now we have 0 to 2. So that's mean 2 divided by 10. So I'm gonna get here is 1 over 5, which is 0.2. For the width is 0.2. So that's mean we're gonna use 1 over 10 anymore? Is that it? Now I start to feel like I did something wrong earlier. Yeah, I think I did something wrong earlier, because earlier is 1 to 2, right? 1 to 2 divided by 10, so you get 0.1 increment. So it should be 1 over 10 plus 1. I think. So you get 1.02, right? And then you do 2, then you get 1.01, then you get 1.02. Okay, but I'm too tired to go back actually. Did I do wrong? Maybe I did it wrong. Maybe I did a small mistake. Okay, but I don't think I can go back anymore. What's done is done. Okay, life, we have to move forward. Okay. Yeah, this thing. Now we get from 0 to 2. How do we do this? So that's mean the scale is 2. So we have to times 2, right? So if we have divide by 10, so 1 over 10. 1 over 10 of a 2, you're gonna get 0.2. 2 over 10 of a 2, you're gonna get 0.4. Right, so if you have half, right, 5 over 10 divide by times 2, then you're gonna get 1. So this is correct. And then 10 over 10 times 2, then you're gonna get 2. Okay, yeah, I think the scale is correct, because you have to times 2 for the width. Okay, so since our scale is, yeah, I think the previous scale is wrong. Instead of time, they should plus, I think, here, plus 1. Alright, it's okay. When I get time, we go back to that. But I think, yeah, 2:30 already, we're almost done with this today. So 1 over n, okay, we have to put 2 here for the range. Does that mean we have to times 2 here also? No, I don't think we have to times here. But we might have to times here. But we already test this and it's correct. Yeah, we already test this. We already test this here and it's correct. Okay, I might have to go back sometime later to just check on the scale because we got 0 to 2. Okay, so our equation is, so this is our first term. Okay, so first term will be this one. I have to put in here, which is 4 minus 1 to the power of 2. I close this. Plus with our final term, which is 4 minus n to the power of 2. Okay, let's see this because we start at 0. So I think 1 might not be valid, is it? Because I think it have to be 1 over n, because the term here is 1 over n. Yeah, same as this, right? 1 over n. So I have to put 1 over n inside here. So here is minus 1 over n, and then this 1 over n is what we squared. Okay, so our first term will be, because we divide it by 10, so 2 divided by 10, we're gonna get 1 over 5, which is 0 0.2. And our last term, we're gonna get 20 out of 10, which is gonna get 2. So that means we have to times 2 inside here, right? But this one is 2 times 1 over n. We got 0 0.2, because n is 10. And then this one is 2 times n over n. So here you're gonna get 2. So yeah, I think it's correct. Okay, even though it's like conflicting in my mind. So 2 1 over n, and then here is n over n is 1. 1 times 2 is 2, so this is u minus 2. Okay, again this thing, so n can be divided and 2 can be divided, so that's mean we are left area will be equal to this, square root 4 minus n, okay, 2 times n, 2 over n square plus third. Okay, this one we can solve actually, because 2 to the power of 2 is 2. Oh, goddamn. Damn, I think I'm done. Okay, 4 minus 4. Do we have a square root 0? Square root 0 is 0. So that means this thing we don't need, because this one is square root 0. Okay, so this thing we don't need. So we left with this. This is our total area. Okay, so that's mean we're gonna get this. This is our total area. So now we have just put the n term. Is the n term is 10. So if we get n equal to 10, so that's mean 4 minus 2 divided by 10 to the power of 2. Okay, so just put this in calculated. Now it becomes so simple. And then when it's this simple, I got doubt. I feel like it's wrong. Alright, so I got 1.99999899. Is this correct? Because here, see here, the I should get pi for this, which is I don't get pi. Not interesting at all. Alright, the area should be equal to pi, and I don't get pi, so that's mean my answer is wrong. Okay, I might want to do this again. Okay, what mistake did I do? Wait. I think I did a mistake here. Like 4 minus 2 over 10 square 1.98. I think pi should get 3.412. Okay, this is a big problem now. Maybe this is my limit. Maybe I'm stuck here. Or maybe the time. Maybe we're running out of time and energy. This is the best I can do. Wait. Okay, let's see. Yeah, this is so weird. 2 to the power of 2 is 4. 4 minus 4. There's definitely 0 on the back. Okay, I'm missing something. I'm missing something big. Okay, let's kind of go back here. Okay, what am I missing here? Okay, this is the equation, which is this one. Okay, let's try to rebuild this equation. N over 2, so we got A plus L. Okay, this is the first term. So first term is the n equal to x equal to 1. It shouldn't be x equal to 1 the first term, I think. The first term should be x equal to 0. Or 0.1. Yeah, that's it. But that is what we are doing. 2 times 1 divided by 10. N is equal to 10. That's crazy. Two times I'm kinda stuck. Okay, so let's put it like one by one. N to the power of 2. This one we didn't do the width yet. Okay, so the width should be over here. This is area. What is the width again? Width is the 2 divided by n, I think. Because it's 2. It's 1 over 10. But then the whole range is 2. Okay, I think this one is correct. Okay, and then the first term. Okay, so that means the first term is this square root 4 minus x to the power of 2. Then we're gonna have to input the first term. Okay, and this thing plus, did I do minus just now? No, I did plus. Okay, so this thing plus square root 4 minus, which is, this is the largest number, and then we close the bracket. Okay, so first term, what is our first term? Our first term is the first width. So our first term is the first width, which is 1 over 10 times 2. So you're gonna get 0.2. 0.2 is our first term. So 4 minus 2 times n square root plus, so our largest term is 4 minus 2 times n divided by n square, then close. 10 1. Okay. Okay, and then this one another big bracket, so we got n over 2 times with 2 over n. The thing is, this thing is definitely cutting each other. They're gonna straight up like cancel each other. So we are correct actually. Okay, so given that this is 2 over 10, but I got it wrong. Is there some flaw in my understanding, I guess? Ten times 10 is 100. Okay, 1 over 25. 4 minus 1 over 25, so you got 3.96. But then you square root this thing, you're gonna get 3.96. Okay. Oh, but this is the lower limit. Probably this is correct. Yeah, I forget. This is the lower limit. Maybe this is correct. Okay. So after I done this, right? Okay, this is my fault, I think, because I'm not confident in the answer. Right. So this is the lower limit, but the upper limit would mean it start from instead start from 2, right? Wait. Oh, so we have to change this to 2. 2 times 2. Okay, let's try to upper limit. Okay, let me write down for you. Whoever you are that's still alive right now. So here a is equal to, so we want to do upper limit, we do 2. 2 times 2 divided by 10, and then you square root. Okay, let's see, because this is the lowest one. 2 times 2 divided by 10 square. So here, okay, my bad, maybe I'm just dumb. Oh, I forget. Okay. Actually, I'm dumb. Okay, so here we have to do n plus 1 for upper limit. So that means this one is not enough. So that means we have to plus, and then we have to make another equation. 4 minus square root 2 times, and instead of 10, now we use 11 here because we have to plus 1, and then divide by 11, and then close it. And then we're gonna get 3.30. Okay, now we're talking. Okay. Whoa, I shouldn't doubt my answer, man. What is this doubt? I thought I'm gonna get pi this first time. No, you're not. Of course you're not gonna get pi the first time, because we are doing lower limit and upper limit. Alright, so here this one we get 3.30. Okay, our aim is to get 3.24, is it? What is the number of pi? 3.412. Okay, 3.142. Okay, as long as within the range, it should be correct. So 3.3. So now the range is 3.3 to 1.98. Okay. Alright, next one we're gonna have to do for 50. Okay, I think this is last one. Then we can stop. Dude, I kinda need to study this actually. 100, 200, 1000. 50, 100, 100, 200, 1000. You don't need to do this much. Okay, let's do this one again. Okay, let's do lower limit first. So now we do 50. Oh, divide by 50. Then here gonna be, okay, we start at 1 again, but now this time we're gonna divide by 50. Okay, I don't think we need anything else because everything else have been cancelled. Right, so here, what is this? This lower limit or is this upper limit? 3.4. Wait, did I do something wrong? Oh yeah, I forgot to square this. Not this. Not square this. But I have to square the inside here. Okay. Alright, now it's correct. So I got 1.99. Then if I do upper limit, I should do 51. Alright, to actually understand this is kinda crazy. Very interesting. Oh, math error. Okay, what did I get math error for? Is it 51 divided by 50? Okay, that's so weird. Okay, maybe I have to stop really soon, but let me try to use Desmos calculator. Desmos scientific calculator, let's go. Okay, what a complex equation. So 4 minus, what do we have here? 4 minus 2 times 1, 2 divided by n, which our n right now is 50. And then this thing I'm gonna have to square. To the power of 2. Okay, but then we have another one, which is of the plus, and then another one here, and at the same time this is 50 times 50. Okay, but then upper limit should be 1 here. Undefined. Why is it undefined? Is it a negative number? Square root of a negative number? Oh, okay, I see, yeah. Because 4 minus something. Okay, so does that mean this is the limit? Limit of the equation that I create? Probably there's a better way to write this equation. Because we're doing n plus 1 and then divide by n. I don't think I can continue because if it stop at 50, how about 100? But then I can do with 1, so that's weird. Yeah, I can do with 10, so it should be the same. Like if this one is 11, this one is 10. How? Oh yeah, it should be undefined also, but just now I didn't get undefined. Okay, what did I do? Did I do something wrong? Here is n plus 1 square. 2 times n plus 1 square. How do I get this again? Wait, how do I get this? Yeah, it's so weird. How do I get this? I do exactly the same thing. I do exactly the same thing. Ah, oh my god, I'm inside my own trap. I'm trapped. 4 negative x square, 4 negative x square. So, okay, this one cancel. We don't have to like that. 4 2 divided by n square plus 4 2 2n plus 1 square. Oh. What a problem, right? 1 plus 1 over n. How about that? How about that? Is that correct? 1 plus 1 over n. Okay, so that's mean 2 plus 1 over 1 plus n. So that's mean 2 divided by 10. Also undefined. Wait, how did I get this? How did I get this number? That's crazy. What did I do? Did I do something wrong? 10 1. Okay, I might have a misclick or something. I think I am at my limit. I'm done. Here's my limit. Done mathematics for today. That's all, folks. Okay, 1.999. 1 out of 10. We're not even at the real calculus yet. Let me see the syllabus. Okay, I kind of stuck in this question. Okay, then we actually supposed to do this, which is the real integral. Well, I think but doing this exercise is important for this thing. Actually understanding the integral. Okay, how many pages of this again? It's 16 pages. Yeah, Newton and Leibniz. And then we got exercise. Okay, yeah, this thing, limit and stuff. Okay, I need to solve this. Can I continue without solving that? Application of integration. That's interesting. Oh. How did I get this? What did I do wrong? Square root? Did I not square root? Okay. So first term is this one. 2 divided by 10. And this is the final term. First term is 1 over 10. should be 2 times 2 here. Maybe that's why. Maybe that's why. Should be 2 times 2. Whoop. But then no, we're not doing this one. We're doing the first term. So for first term, oh my god. Oh, okay, it's just a group. Why am I having group? Okay, so for first term we start as 1, and then this one is n. So that means this one is 10 divided by 10. Oh, maybe this is what I do wrong. Shouldn't plus, I should times. Okay, yeah, this one no problem. Right, this one no problem. But then here we have put this 2. Then I put this as 11. This is where you got a problem. Yeah, undefined. I understand why it's undefined, because it's a negative square. Like a square root of negative number, you're gonna get undefined. Yeah, because it's a imaginary number. I understand that. Okay, the problem is how did I get this thing, and it's quite close of an answer. Hey, because I use this calculator. Choose this one is 2. But now it just give me math error. That's because this thing is capable. This thing is capable of getting the answer with square root negative 1. Math error. Square root negative 4. Math error. Oh, I should use complex, is it? Maybe I should change this to a complex number. Where is the complex function? Give me some complex mode. Okay, is that? So I got this. So do I able to change this into a number? How to change this? I mean, can I change this into this? No. Please change my answer. Change this into something recognizable. Oh, here. No, I don't want to. I. Okay, minus. Can you give me my answer in fraction? No. What is this? Braille mode? How are you gonna use Braille reverse contrast? This. Try writing. Yeah, I know. But how do I change this? Can you change this into like normal number? Cannot, because it's a complex number. I shouldn't get a complex number here. Alright, that's it. Maybe I should go sleep and then see if I can do again tomorrow. Goodbye, everyone.